asked questions about my Burnout kiln. So I thought I'd put together a little video. When I built it, I wasn't doing videos, so I don't have a lot of good historic photographs, but I have a few, and I'll put them in this video. Basically, I had never done a ceramic shell burnout. I had gone to one foundry in Dallas, Schaefer foundry, that my wife was using to cast her work, and I saw theirs, and this is pretty much a copy of theirs because that's all I knew. I did know that I wanted a strong frame because, one, I built this at my house and I knew I was going to have to move it here, and I didn't know what sort of equipment, if any, I would have to be able to pick it up. So I'm envisioning dragging this thing into a trailer with a cummel on or something. So I wanted a really stout frame, and I got lucky. I worked heavy construction, and we had a diesel pump. I think it was a 4-inch pump that died, and the pump was mounted inside a frame made out of this 2x2, 3x3. So I brought the frame home and cut it up, and all these are welded together because most of the pieces were pretty short. The bottom part, where you can stick a forklift forks. So the bottom part was a big electric air compressor that I got during the demolition. The air compressor was long dead. It was rusted solid, but I got a lot of metal from that. And the bottom and where the forks go pretty much was directly off of the air compressor. So I built it. Exterior frame size basically on what I saw in Dallas. The one in Dallas was a factory purchased one, and it was built with fire bricks, and it probably weighed 2,000 pounds. I went with the white ceramic shell, 1-inch insulation. I put 2 layers. So this one, except for the frame, this part is pretty light. When I bought this building, there was an oil containment vessel on site, and I ended up cutting it up and getting a lot of square footage of this. It's sheet metal. I don't know the gauge or the thickness, maybe 3/32. It was heavy enough that I can weld it, and I'm not a very good welder. I just made it's a 4-sided box. I didn't make a bottom. The bottom is different. The top, I put a arch in, and I don't really know why. I just thought it looked cool. I thought maybe it'd work better, and I didn't know what size chimney to make on the top, but I figured I could always choke it down. I couldn't make it bigger, so I made it pretty big. I don't know if you can see it, but there's a plate covering about half of it up, and it seems to work okay like that. I really haven't done any scientific experiments. That's how it works. So I start out with the exoskeleton, the big heavy frame, a sheet metal box suspended in the middle, and then I fit and attached the ceramic shell insulation. Let me open the door. There's 2 layers of 1-inch insulation on the 3 insides, on the back side of the door that opens, and around the chimney. And this stuff is really easy to work with. It's kind of fragile, but it's easy to work with, and it's not expensive. It is attached with these little things. Basically, you just weld this. You weld this side to the inside of the sheet metal, and you punch the ceramic shell so that it just pokes through, and you got this little keeper with this little hole, and you push the ceramic shell till it's snug, and you turn it 90 degrees, and that's it. That's all there is to it. And the ceramic shell, looking at it, it's got some soot because I've had some bad burnouts, but it is for the most part exactly like it is when I put it in there. Jesus, it's been 4.5 years, I guess. So I'm real happy with the ceramic shell. I mean the ceramic fiber insulation. It's not a durable product, so I didn't want the sliding door rubbing on it. So I spent a good bit of trouble. See if I can show this. The door rides on these little rollers, and the rollers come down this little track. At the last minute, the track turns in, so the door rides up and down without rubbing the ceramic fiber insulation, and then at the last minute it closes in. I'll see if I can show you. The door's coming straight down and it's not touching, and when it gets to this point it goes in, and it makes a pretty good seal, because you know I've been burning this thing for 4 years now, and there is no heat loss coming from the sides of the door. Now at the top, right up here, a little bit, but not a huge amount. And the original gray paint that I painted the thing with is all intact. It's all intact except for right there, which means the heat is staying in the box where it's supposed to be and not leaking all over the place. Okay, when I first built it, I put a burner on both sides, this one at the bottom, and I put this one at the top right here, thinking that would give me good heat distribution. Well, what happens is all the heat rises, so this one doesn't really do any good. All the heat goes out the top. So it wasn't long before I moved it further down. So both of my burners are near the bottom, this one in the front, the other one in the back. These are nothing more than Harbor Freight weed burners. I drilled the orifice a little bit because I'm not running on propane, I'm running on natural gas. I do have a 2-pound meter, which is a commercial pressure. Typically in a household, the natural gas is delivered in ounces, like 4 or 5 ounces, but I have 2 pounds because I'm commercial and I asked for a commercial meter. So it's the orifice is drilled, and I grinded a hole on the bottom of the burner, and let me get over here. Yeah, you're not gonna be able to see it, but I burnt this support tube. I burnt a hole in the bottom so that I can hold a match, and the match will go and light the burner without me having to stick my hand inside the kiln. I bought 2 very, very inexpensive pyrometers from eBay, and they have worked just amazingly well. The little tube goes into the box right there. The little deal that operates off a 9-volt battery is right there. I did notice after a while that they were getting kind of hot. If I have a long burn, like when I burn out wood or plastic, I burn for a long time, and some of the heat was coming through, so I ended up the little mounting bolts, I made them real long, and I put some ceramic insulation, and so that took care of that. The door is fairly heavy, so I have it counterbalanced with this cable. It runs up to the top on a sheave, runs over the back with another sheave, and I've got 3 or 4 solid round bars, and it is it's not quite perfectly balanced. It still has some weight to it, but it makes it real easy. When I watched the guys at Schaefer do a Burnout, they had a guy with a moon suit. I mean, he was covered head to toe with aluminum foil. He looked like an astronaut, and he was opening the door and sticking his head inside the furnace and grabbing the molds and handing them to somebody that was outside. And I said, poo on that. So I made these guides, and I made the tray that holds the, well, that would hold the molds up. I made it slide in and out, thinking how smart I was, but it did not work, not one single time. It got hot and expanded and got jammed, so then I cut it and made it smaller, and it still got jammed, and messed with it some more, and it would twist, and finally I just gave up on it. And for a couple of times I stuck my head in the furnace to get hot molds out, and then that's when I built my tongs, and I have a video in those, and they have been working perfectly. So To do a burnout, the wax has to go somewhere, or needs to go somewhere. So the doors, the bottom doors open. Now my first burnout, I did that, I forgot to lock them fully open, and what happens is the hot wax hits those doors, it's on fire, and all of a sudden you have a big giant fire. It's important that these doors are locked like this. Vertically, and then the wax doesn't hit them, and the wax falls into the water pan at the bottom, and that one puts out the fire because it's almost always on fire, and also it makes it easy to salvage the wax because it doesn't stick to the water. Now these doors I just made up. It's a metal frame, it's insulating bricks. I've got real fancy, I got 3/8 steel bars running through the bricks, and I sized them exactly half of the interior. I propped them up with some boards in place, and then I started fritzing with the counterweight system, with just kind of designing it where it would work and balance, and it's real simple. It is. There's a pipe here, and it pivots in some welded angle iron. It's got a lot of weight because they're fairly heavy, so it's a counterbalance. But you can just push them down and lock them closed. That's been really good. No problems with that. What I have had problems with is the bottom of the furnace on the inside. Let me open it up. So when I was doing a burnout, I had the doors open, the mold's in there, fire's on, it's getting hot. It won't get too hot with the bottom doors open. It won't hardly get to 800 degrees, but it's hot enough to melt the wax out. So when all the wax was melted out, I would close the bottom doors, and the temperature would jump up real quick, and I'd burn out molds. Typically have them at 1700 degrees for poured bronze, but sometimes I would, when I was burning out sticks, I'd bring them up to 2000 degrees and keep them there for a while. And that was causing the bottom to bow badly. And I tried to repair it a couple of times and gave up. The grating kind of disintegrated, so I got rid of the grating, and I had a bunch of these round bars, and I made a bottom out of these round bars, and a couple of burns, and it had done the same thing, and it had actually bowed down so bad that I couldn't close the bottom doors. So unfortunately I had to take it all apart, beat them all straight, put it back together. No longer do a wax burnout and immediately bring the mold up to temperature to pour. What I do now is I do a wax burnout, turn off the kiln, and then I have this kind of falling apart now, but I have this is 1-inch ceramic hardboard I cover the bottom with, and then I reinstall the molds, and that insulation board kind of protects the bottom, and it hasn't warped since I've used those, but it does require me to have a 2-step burnout, which is okay. It's probably better because I should examine the molds prior to pouring bronze in them anyway. So then when I first started, I built this hood, and this is just built out of junk, and I put an exhaust pipe, and I put a blower thinking I would have a power blower to remove the hot air and the smoke. Well, burn one, the blower burned up, and that was because my wax was on fire. So I bought another blower, and even without the wax being on fire, it burned up. It's just too hot up in there. So I took out the blower, put in straight pipe, and it evacuates really well. I don't have, I've had some sooty burnouts, and I don't have soot in my ceiling, on the light fixtures. Keeps everything pretty clean, so I'm pretty happy with that. Let's talk about things that don't work. If I had to do it over again, I would not go to the trouble of making this sliding door. I only made a sliding door because that's what they had at the Schaefer foundry. It's just overly complicated. It reduces my height right here by about this much. So sometimes with tall molds, it's kind of awkward. You got to bend them and get them in there. The worst thing about it is when it's at 1700 degrees and I'm ready to pour, I have to come over here and open it. I got a face full of really, really hot air. And if I had an open swing door, it would be simpler. One, I could have more headroom in the doorway itself, and I wouldn't get that uncomfortable feeling of all that hot air coming out after me. Let's see what else I would have done. I have a main valve on the back wall. You can't really see it, it's behind the steel. If I had to do it again, I would put it in a remote location, because if there is a fire, probably can't get to it. I'd have to run to the building up front where I have another valve. On my furnace, I have a valve over here on the wall that's 10 feet away. And on the wax stove area, I have a valve that's 10 feet away. But on this piece of equipment, the valve is right behind it, which is probably not the best of things. What else would I have done different? This is the hole from the original burner that I moved down. And I use it as a peephole, and I really like it, and I kind of wish I'd have put another one. And if I had to do it over again, which I might one day, I think I would use some sort of refractory bottom with holes in it so that it could take the heat without warping. The big boy foundry that my wife uses now for bigger work in Colorado, that's what they have, and you know, they burn every single day and it seems to hold up. So maybe one day I'll swap out this bottom for a refractory bottom. And my pan for catching the wax, which was the holding tank in my boat, a stainless tank that I cut in half. It could be a little bit bigger because a lot of the wax misses and splatters on the floor and makes a big giant mess. Other than that, I'm pretty happy with this thing. So hopefully, if anybody's planning on building one, maybe they can pick up a few tips on what I just babbled on about. Thanks for watching.